Number 15, I'm going to highlight what's important in the problem. So the mean increase, this is what they're calling their mean. Standard deviation, 1.24. So the Sasha picks her own. She picks 100 companies. That's your sample size. That's your N. She comes up with a different mean, 7.08. And she states that they can make more, right? So that makes it a one-tailed test. So here's the null hypothesis, as the mean states that the mean is 6.62. The alternative is the mean should be greater than 6.62. It is a one-tailed test because she believes that her outcome is going to be greater than. We have to calculate the test statistic, right? There's a z. So the x bar is her mean, 7.08 minus the stated mean of 6.62 divided by the standard deviation, which is then divided by the square of the sample size. That comes out to a z-test score of 3.71. You got a couple of ways to look that up. You can look that up on a table. It's going to be really, really, really small. Okay, but we're going to use the Excel spreadsheet. We're going to use this one. Okay. It will give you the same probability values as a table will. So let's copy that. And we'll put that in our little box here. Paste. And get rid of everything except for everything to the right of the equal sign, and our z-score was 3.71. And again, it's going to be, you should expect it to be practically 0, because what this says is that it's 3.7 standard deviations away from each other, and that's huge. And there's your p-value right there, and right, 0.0001. Tiny. And guess what? You are going to reject the null at that level. So in other words, her choices were significantly higher than the stated choices. So that's it. MGZ out.